Yeah, and thanks for having me today. I appreciate the introduction and wanted to talk a little bit about DevSecOps today, and I'll explain what that means here very shortly. And thanks for the great introduction. One of the things I wanted to mention is that I am a developer in addition to also being an information security professional. So I actually started my career developing software for warehouses and supply chain logistics and waterworks and a large transportation logistics company. And so definitely have development at heart. And I still develop software today. I just do it as an open source developer since I'm doing information security professionally. To start, we have this term DevSecOps, which is really an amalgam of these, of course, acronyms. It's information security, right? So we'll have to have it a minimum of 25 acronyms today. And it stands for development, cybersecurity, and IT operations. And it takes the letters from each of those and combines them together. If we take a typical life cycle for an application and lay it out sort of in this line here, and then we can divide that in half, we have the development processes at the top. And so we think about what project we might want to have, and we imagine what it could be. We might even go ahead and develop the project, write some code, bring some other people's code in and build the project and test the project. All of that is all development activity. We're creating the product. If we look at the bottom of the life cycle, we're now releasing this product to the world, letting folks use it. The product is running, it's running in production, and the users are getting to enjoy it. So we have dev and ops, or DevOps. And you'll notice that security is woven throughout this entire process. Right from the beginning where we first thought of the project, we have security standards and requirements. And then all throughout the development, we're constantly assessing the system. And then all the way through ops, we're constantly monitoring the system. So security is really tightly woven in the entire process. And so when we put all that together, we get DevSecOps. The question always comes up, why would you want to do it this way? Well, if we take a step back for a minute, for one reason, if we have a bug in our software and that bug isn't caught, it'll naturally tend to replicate itself. So you think about a mobile application with screens, or you think about a website with web pages or other interface. If there's a problem on one of those screens or one of those pages, we tend to copy the code that we can reuse from page to page, or we tend to put the code into a library and all the pages all use that code. And so as we create more and more functionality, these bugs are replicating themselves. They're getting literally copied and pasted and ending up all over the place. If we can find an issue early on, as early as possible, we can go ahead and fix the issue and maybe even make a little documentation or something so that we don't make that mistake again, perhaps share with our team. But obviously, if that bug is fixed, if we replicate that functionality, if we replicate that page, if we replicate that screen, the new screen is not going to have the issue, is it? Because we already fixed it before we copied the code. Another issue is that having a security problem in a system can be very disruptive. And what we'll notice is what tends to cause the disruption to be a certain amount is really time. So if we have a problem in the development phase, it's inconvenient, but it's really not that big a deal. The developer just stops what they're doing for a moment. They fix the issue. They might create a note or a comment to kind of warn others on the team. They may even have a little webinar or lunch and learn or a team building session and talk about the problem that they found. And so they can share the issue with others so that it just doesn't happen again. But there's really not much friction, is there? We don't need to change control. We don't need to have a down window on Saturday night. We don't really need to have a conference call to talk about it, right? We just fix the problem and we learn from our mistakes and we move on. There's not a whole lot of fanfare. If an issue gets into the build process, now that problem is starting to interrupt the build itself. So certain gates or checks won't let an application that has a problem complete the build process. You have to go back and you have to fix the issue. And ideally, all development pipelines would be that way. We certainly don't want to promote code that's got a problem. We're only delaying the inevitable, and the costs are only going to go up higher later. Also, the bugs are starting to replicate at this point. They're creating copies of themselves. They're getting bigger. If the issue goes to the testing phase, you can almost be sure that there's going to be some impact to the project timeline. It may be a little impact, it may be a lot of impact, but at this point, we're not going to get away with it anymore because we've now involved other groups. We've involved the test team, the user acceptance testing team, perhaps, which could even consist of beta users or close customers that are checking the software. And if it isn't working as expected, it's got to go all the way back over to the development team. It's got to get fixed, come back through the build process, only to end up in testing again. So what tends to happen at this point is the mean time to repair is increasing. That's the time from when we figure out that we have the problem until we actually fix the problem. And of course, when bugs make it this far down the road, it takes longer to get them fixed because you have more teams involved and more processes that have to be repeated. So we're stretching out those timelines. If the issue makes it all the way into the production environment, this is where it's going to be the most expensive. The mean time to repair is going to be its absolute highest. We will very likely need down windows, change control, and other bureaucratic processes to manage the change so that we can fix the bug and redeploy the code. We could have issues with regression, meaning like something that was working fine is now broke because of the patch that we put in to fix the bug. All sorts of problems happen at this point. If we don't fix it in the production, someone else might find the security problem and they might take advantage of it. And of course, that's the worst case scenario. But all in all, we would say this is all disruptive. Less disruptive certainly earlier on, but disruptive nonetheless. And the further to the right it gets, the worse it gets. But security assessments can be integrated and automated. In fact, that's what DevSecOps is. We integrate security tightly into both development and operational processes. So in development, we would have automated peer review, sometimes referred to as static code analysis, where we're literally just looking at the code with, other software. And these security tools can examine the code and find problems. We can also have the same type of testing in the build process, because we're not just developing software using software that we write ourselves, but we're pulling in libraries from other people too. We use open source components. Matter of fact, something like 80% of projects now include at least one open source component within them. And I sometimes jokingly refer to that as other people's code. We have the code we write, our code, and we have the code that we borrow from others, their code. Once we actually get to the testing phase, we can start to do what's called dynamic vulnerability assessment. It's really a fancy term that means scanning. We can fire up security scanners and interact with the application. The reason this is occurring so late in the process is you have to have an application built in order to be able to interact with it. So static analysis we saw can happen really early on because we're just looking at the code. Dynamic analysis, where we have to interact with the application, requires that we build the application first so that we have something to interact with. This is also the time when we can do something called instrumented vulnerability assessment. This type of assessment is happening on the server itself, as opposed to some scanner sitting off at a distance and it's scanning the application across the network. An instrumented vulnerability assessment is happening on the application server, right there besides the app. And we'll talk a little bit more about instrumented here later. Again, if we wait until we get into production, that's too late. That's actually not development anymore. That's operations. And the code has already been pushed. It's already been released out to the public. Folks are now using the software. If it's an internal app, our employees are using it. If it's an external app, our customers are using it. But nonetheless, it's too late to be fixing issues. So what we're already seeing is timing is really everything. We're going to have issues, and they start off small in number and small in disruption. But over time, those issues will naturally replicate. And if they'll get over to the build process, we're now bringing in other people's code, which inevitably will have bugs in it as well. So we're picking up bugs from not only our software, but from the software that we're borrowing from different libraries. Well, once we get down into the test phase, we're going to be deploying our application onto servers so that we can run the app. Well, those servers are going to have issues. So now we have the bugs from our software and their software, plus the bugs that are already inherent in the server software. And you can see how even through really no fault of our developers, we're still accumulating security issues if we don't deal with them as early as possible. Now, if we deploy this system into production, we'll have the same number of issues, but those issues are going to be a much bigger deal. They're going to be more disruptive and take up more of our time because it's harder to fix things once they're out into the production environment. It costs more money and resources to fix the same issue that we could have fixed cheaper if we had fixed it earlier when we had more choices and less disruption. We can kind of put some lines in the sand, so to speak, onto our diagram. The yellow one represents the last chance we have to be proactive, and this happens really early in the project. So right here, we have the ability to make a plan to include security controls and to implement those controls when we start developing the project. And hopefully we're doing that. We're making a plan and carrying out our plan using something like the application security verification standard from OWASP to set our requirements for us, or some other set of security requirements. If we don't do that up front, inevitably we're going to be in a reactive mode. Yes, we can scan and find bugs, and we can hire security testers to come in and they will find bugs for us, and those are needed activities and they should occur. But that's reactive in nature, isn't it? If we were to have a more proactive approach by putting the security controls in intentionally into our systems up front, we could avoid having the bug in the first place. The bug will never have existed. If we are scanning and finding issues, that by its nature is reactive. We're reacting to the information we're getting from the scanners and then doing something about it. The other line, which is even more important, is the line between the dev phase and the ops phase. So this is our last chance to fix the issue at all. If the security problem crosses that line, we are now putting a vulnerability out into production environment. And at that point, it's going to be a matter of luck as to who finds it first. Is it going to be us, or is it going to be somebody else? If a security problem makes it over here, it really is too late. We're going to pay the maximum price to fix it, and that's in the best case scenario where we happen to find the problem before somebody else does and takes advantage of it. So it really is all about the timing. And you might say, well, why would a management team worry about these sorts of things? It's really resources. We deal with bugs early in the life cycle. It saves money. It saves opportunity cost where we could have been doing something better with our time, but instead we ended up getting stuck having to take a time out and fix some issues. It also costs us frustration. Once it gets to the build process, we're now spending about 10 times more to fix an issue that could have been fixed when we were developing the code. And what's interesting is that if it makes it all the way to test, it costs about 10 times more again. So test is 10 times more expensive than the build, but 100 times more expensive to fix the same issue that could have been fixed during development or proactively avoided. And if it gets into operations, it's, you guessed it, 10x again. So now we're paying potentially up to 1,000 times more to fix an issue that could have been avoided or fixed during the development process. But it really doesn't stop there with security issues. A security issue can manifest itself as a bug, which it is. It's a defect like any other defect, but it can also become a security event, which has its own cost associated. Additionally, it can also be a compliance failure. And it can do all three of these at the same time. So these are what's known as parallel disruptors. They can manifest themselves in multiple ways at the same time. And each of those problems, each of those manifestations has a cost associated with it. And if it's all occurring at once, the cost can really add up. And it can actually be more than 10x. So what we noticed is that vulnerabilities have to be stopped no later, worst case scenario, before the end of the testing phase. That's our absolute last chance. The earlier the better, the earlier the cheaper, but certainly that is the line in the sand that we don't want to cross. So what do we do? What actions do we actually take to pull this off? Well, before I get into giving you some examples for illustration of some different tools, let's talk a little bit about the types of security testing that are occurring. And then that'll help make more sense out of the different kinds of tools that you might run across. I was doing some checking earlier this week, and there's more than 30 tools available just for DevSecOps testing that are kind of popular names, and I'm sure there's many, many more that are from smaller companies that maybe we haven't all heard of. So there's a whole lot of choices out there in the marketplace. Well, there's essentially 5 different kinds of security testing at a high level. We have the static application security testing. This is the peer review that we were talking about. When we're doing this same type of testing in other people's code, in those open source libraries and those other components, that's called software composition analysis. We had that interactive testing where we were talking to the app. That's the dynamic application security testing. And then we had that instrumented that we said we were going to mention later. The 5th type doesn't make a mention in this particular presentation because we're talking about fixing problems in development, but there is a cousin called RASP, or the type of security assessment that happens in production, where you basically have an instrumented application agent watching over the app, protecting it, guarding it, but that's happening in production in real time. That's not a development process, so that can't help us here. This all starts with the pipeline. Now, there's lots of different brands. Some more popular ones include GitHub and Bitbucket, Azure DevOps, which used to be called a Team Foundation Server, or TFS, but was rebranded a few years back. This is where we store the code. The code has to be in a repo, in a place where the tools can get to the code. So you got to have a foundation to put your code into that is smart enough to not only be able to store your code, but also can allow these different security tools to interact with your code and interact with your project. You'll also see tools like Jenkins brought in that are orchestrators, and they allow you to have a place to start up all of these different types of assessment running, so that when your code makes it to a certain point in its life, a tool like Jenkins can say, oh, you know what? It's time to check for secrets. It's time to do software competency analysis. And it can automatically start up the tools running for you so that you don't have to manually go in and run assessments and manage reports and those types of things. So this pipeline is really going to be the foundation that we're going to work from, regardless of which brand you choose. The static application security testing is able to find certain bugs during development. And it does this by looking at the code. It just reads the code and does an automated peer review. This is the earliest type of testing because it can start as soon as we hit the keyboard. It can integrate directly into the development environment. So if we're using Visual Studio or Eclipse or some other tool to write code, plugins from the SaaS products can sit there inside of our integrated development environment and watch us write the code, and we get that real-time feedback that something is wrong. It does have its limitations. There are certain types of vulnerabilities that you simply cannot find by looking at code. Imagine a misconfiguration in a TLS certificate, or there's a potential cross-site scripting vulnerability that is, a stored cross-site scripting vulnerability. Those are hard to detect just by looking at code. You have to actually interact with the application. So don't think of these different types of assessment as being choices. They work as a team. They work together cohesively. Each one of them is only able to find certain bugs, not all bugs. And you need all of the different kinds of assessment together as a group in order to get a comprehensive picture of what the application or system really looks like. So some examples of some of these static application testing tools would be SonarQube is popular, and Insider CL. And then there's all sorts of paid products that are available as well, in addition to these that you can try for free. Although SonarQube does charge for enterprise support, so there is a point at which you would end up paying to use it. The software composition analysis is still essentially static application security testing, but it's not of our code. This is testing the other dependencies that we're using, that we're borrowing from others. So if we would like to use an open source library, say you're writing a website, it's very common for websites to use jQuery or Bootstrap or AngularJS or some other components where the developer isn't going to reinvent the wheel. They're just going to go ahead and grab a library and integrate that library into the project. And that way, some of the code's already written for them, and they can just go ahead and leverage that. To test these types of dependencies, we can use a tool that is dependency aware. Essentially, they're scanners that keep track of the weaknesses that are in different open source products and the version. And so as the version number changes and vulnerabilities are patched, the databases are updated, and these types of products would realize that, hey, you're using version 3.0.1. You should be using version 3.0.4 because that's been patched. And they can alert you to that fact and give you a heads up that you need to pull down a newer or a patched or fixed version of whatever product you're using. Some examples of this would be OWASP dependency check, which works well, and Yelp detect secrets. So dependency check is going to look at all your dependencies and make a list and do those checks like I just explained, checking the version, checking the problems with each version, and suggesting to you if you need a newer version. Yelp detect secrets is scanning the code looking for passwords, credentials, private keys, and other secrets that might be embedded in the code that shouldn't be there and that you would want to pull out and use like a secrets manager instead of having a password or a private key or something hard-coded into the source code where just anybody can read it and get a hold of your secret. The dynamic application security testing is the one that was interacting with the application. This type of testing is not able to see the code. So it's not going to be able to find some of the security issues that the SAST or the SCA could detect, but it has the advantage that it's talking to the app, which means it can find security problems that the other two cannot. Again, these all work together as a team. One does not replace the other. They are all required. So DAST products would be like OWASP Z attack proxy. It's usually just called ZAP. And there's also SSL scan and other products. And what a tool like ZAP would do is interact with the app and fuzz it and send in all kinds of input. And based on how the application responds, it can find all kinds of vulnerabilities like cross-site scripting, or it can find SQL injection or other different kinds of issues. And there may be overlap. So take, for example, the SQL injection. Well, SonarQube should be able to detect that. It has access to the source code, and that happens to be a vulnerability you can detect by looking at source code. But Zap could interact with the application, inject it, and based on how the application responds, find that same vulnerability. So while all the tools are necessary, there may be a little bit of overlap between the tools. But I do want to continue to point out that they're not replacements for one another. You have to do all of the different kinds of assessments so that you can get that holistic view of the app. A tool like SSL Scan will check TLS configurations. Is the certificate any good? Are the ciphers being used strong ciphers, or are they worn out, too old? And so those types of issues can be detected with these tools. And of course, again, as always, there's all kinds of commercial products as well. I'm just mentioning the ones that are free for you to try for yourself. The instrumented application security testing is also somewhat in the dynamic category. It's kind of like a cousin of the DAST scanners, but there's a really big difference between the DAST product, which is really a scanner sitting somewhere out on the network that's scanning from afar, and an IAST tool, which is installed as an agent with the application. So the app and the agent are running side by side right there with each other on the same server at the same time. And this IAST agent, from its position right there on the server, can keep a close eye on the application as it's running. And it's able to find issues that simply can't be found any other way because nothing else has that kind of access to the running app. The IAST tools and the DAST scanners can also work together as a team. So you can imagine a scanner sending an injection from across the network and the IAST tool watching what happens to the application as that injection arrives and is processed by the app. So tools, and this one is commercial, but tools like NetSpark or Shark can watch NetSpark or Scanner, and they can actually exchange messages through the application headers and talk to each other during testing. And it allows those types of tools to confirm vulnerabilities that otherwise might have been marked probable, or eliminate issues that really weren't a problem that would have shown up as false positives. But when we get into the instrumented testing, we've kind of crossed a line. This is an advanced technique still, and someday may become a little bit more just easy to do and commonplace and no big deal. But right now, it's still a little bit of an advanced technique that you would want to do after you've implemented the SAST, the SCA, and the DAST, and you've got all that working really well. Then you would step up to doing IAST. And Contrast offers a community edition that you can try. And Contrast also has a paid product as well. And so, but at least they give you an opportunity to give it a shot for yourself. So let's lay out all these processes back on our timeline. Well, we made sure we're using an integrated pipeline to store our code. That gives us the ability to examine our code. We can make sure we're implementing the best practices and the security requirements. So we'd want to have something like the OWASP ASDS that we mentioned earlier as a set of requirements or other security requirements. We're going to do the static application security testing early on because that's just looking at the code. So we can do that right away. And as soon as we start pulling in open source or third-party dependencies, we can start to do software composition analysis, which may actually be almost as early as the SAST. Those can be done almost simultaneously sometimes. Later, once we have a project that we can interact with, now we can do the dynamic application security testing. And we can also do that instrumented testing. Before we release the product out to the world, we would want to go ahead and do the security penetration testing, where we're bringing in a third party to verify what we think we did, which is we think we got rid of all the bugs, right? But we want to have a pro come in and make absolutely sure of that. And we will continuously monitor the application throughout its lifetime, because every week, if not every week, at least every month, there's new vulnerabilities coming out for applications all the time. So as an application is sitting there running, minding its own business, its security posture is getting worse and worse and worse naturally, just as a consequence of the fact that new issues, new vulnerabilities, new exploits are constantly being developed. And so, the joke is you go to the developer and you say, hey, I found a new security problem in your application, and they say, I don't understand. I haven't changed that application in months. And the security person says, exactly. Right. So, well, I didn't say it was a funny joke. But this is also where bug bounties and disruption happen. And unfortunately, if there is going to be a security event, this is probably where that's going to happen as well. So we need to keep an eye out on those applications as they're running. Now we can kind of overlay some of the tools that we talked about. Again, these are examples for illustration, but I chose them for the presentation because they all have some either free license or at least free to try license so that you can try this for yourself. So GitHub is an example of a code repository. And then we have the OAuth Application Security Verification Standard, ASVS for short. That would be a set of requirements, a set of security requirements, mostly for web apps. And then we had SonarQube, which can do the SaaS testing. And also there's a product called Linters, 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 that can check the syntax and do some security checks. And they make a nice companion for products like SonarQube. So Linters are not truly security testing tools per se, but they do test aspects of security, even if it's not their prime directive. We talked about OAuth dependency check for doing the software composition analysis. In other words, checking all the different third-party libraries that we're using. And Yelp detect secrets to look for passwords, credentials, or private keys that we accidentally left in our source code. Once we have the product developed, we can start to use OAuth Zap with its plugins and SSL scan to test our TLS configuration. And we can bring in IAST, or like contrast, to check our application at runtime to see if there's any issues that can be noticed while the application is running in our testing environment. Before we release the code, we do the penetration testing. And while the application is running in operations, we're going to continuously monitor it, because who knows what new vulnerability is going to come out next week. And then we also mentioned that, unfortunately, this is where a lot of our problems are going to occur if we have not dealt with the security issue by this point. So what will we do next? Well, this is sort of a checklist of everything we talked about. We know we want to have an understanding of what the security requirements are as early as we possibly can. We're also going to keep the code in a code repository, do our different types of assessment that we talked about. And most importantly, we're not going to promote the code to production until those security issues have been addressed. And this is an example of one team who put together a process. And so what they did is they created gates. And they said, okay, we're going to check in our code, and then we're going to develop the software. And then at some point, they're using, in their case, they're using JFrog to do their dependency checks. And then right at the same time they're also using SonarQube in this example, and they're doing that SaaS check. So you see how the dependency check of their code and the static analysis of our code is all kind of happening right about the same time. Whatever problems happen, they're recorded in this particular case in Power BI, which is a really cool thing that they built to be able to visualize the issues that happened in the first two scans. Now, later on, the application is finally built and it gets deployed down into a UAT environment. And at that point, they can actually go ahead and scan it with Zap, because now they have something to interact with. And as we talked about, we would probably add in SSL scan at this point too, right? Because we would also want to check those TLS configurations. So this might be an opportunity to improve in this particular process. And then there's two really subtle signs of maturity over here. They're hard to catch. You'd almost miss them if you weren't looking for them. First of all, they don't just assume that all the security tools are doing their job. They actually have another tool, in this case, Burp Suite Professional, that they're scanning, doing spot checks on the applications from time to time to make sure that Zap and SonarQube and JFrog and all the tools are doing what they're supposed to be doing. Because if there was a problem and security issues weren't being detected, how would you know if you didn't double check with a different tool? And so Burp Suite Pro it's not a free tool, but it's fairly inexpensive. It's about $400 a year, something like that. And so in the world of scanners, that's pretty cheap, and it can do a double check for you. Also, another sign of maturity is look when all of this activity occurs. So we finished all the security testing by this pink square, right? They're doing all of this before they do performance and functional testing. They're not carrying security issues into the performance testing and into the functional testing that could impact those types of testing, right? If a security problem makes it into performance and functional, it could mess up how the application works, and they don't want to degrade their performance and functional testing. So this is a really mature process. Certainly, there's a couple of things we could do to improve it a little bit, and that's good to continuously improve all the time. But overall, really excellent example of a real life team who built a process for themselves. So at this point, I'd like to open it up for any kind of questions that you have, and I'll leave my contact information up here if you would like to reach out and while we talk.
Excellent. Thank you, Jeremy. If you have a question, you can raise your hand or you can put it within the chat on the right sidebar. Shanae Newman, if some of those come in, can help sort of generate that on the right side there. And I guess I'll try to start us off and just get some conversation going. When we think about DevSecOps and think about smaller teams that aren't necessarily have dedicated security resources, realistically, what are sort of the first easiest steps to get this ball rolling on a team that isn't necessarily has all the resources that a larger team might have? Does that make sense?
It does. Yep.
Okay.
And actually, that's one of the nice things about DevSecOps processes. The bad news is there's just no way around that it's going to be hard at first, right? Because a team like you described would be facing two issues. The obvious one you already pointed out, which is the resource issue, of course. The other one is the learning curve. So it takes a little bit of time to learn how to set up the tools, how to integrate the tools, how to use the tools, how to interpret the results. And to be optimistic, there's absolutely, Pareto rule, 80-20 rule. You can definitely, even as a small team, you can definitely make a big impact for yourself by picking the tools and getting them integrated into the pipeline. You will reach a point where you're going to have some help. So, but again, 80-20 rule, right? You can improve the security of your application probably 80% by yourself. And so have confidence and give it a try by implementing these different types of tools. Once you get to about that 80% point, you're going to need an expert. You'll need somebody to come in, perhaps it could be as a consultant or as an employee, if you have that kind of resources to bring in an employee to do it full time. But there will be a point to where that type of dev team that you described is going to have some help to get past, to improve more, to get better, if that makes sense. The DevOps tools, though, the nice thing about them is that they're integrated into the pipeline itself. Again, hard to set up at first. It is a new skill, so it's going to take time and patience to get it done. But once you get it running, it's automated.
Yep.
So you think about SonarQube or Zap or Detect Secrets or SSL Scan or the tools we talked about. They're getting kicked off by the pipeline itself. They're getting kicked off by GitHub or by Jenkins or by Azure DevOps. It's not like the developer is, looking at their watch and saying, oh, it's 4:30, I got to go run a scan, right? It's the pipeline is saying, hey, the code got checked in. Because the code got checked in, I need to wake up the scanner and have the scanner do a scan so that the report can be ready when the developer gets back to work in the morning. And it's the automation that really provides a lot of leverage for teams like what you described. So this is really sort of democratizing security to a large extent. Again, I don't want to overstate it. There will be a point to where you are still going to have to bring in an expert eventually, but it really has kind of put these tools in reach of the development teams and not just kind of said, well, those are too complicated. Security is going to have to run them for you.
Cool.
Jeremy, what would be a sign that they need to bring an expert in? At what point will the system let them know that, or would that be at what point will they know that they're doing it correctly, and at what point will they know they're not and they need help?
Yeah, it's a good question. So it's not going to be one thing in particular. There's going to be a few different signs. When a team has trouble interpreting what the scanners are telling them, like the issues are too subtle, they're too esoteric, the development team is struggling to know what to do next. That's a good sign. I call that the bridge problem. So you get the scan results back, right? You have this PDF in front of you or a Power BI dashboard or whatever, right? Whatever report. And you're looking at the report as a developer and you're saying, oh, okay, I can fix that. I can fix that. No problem. No problem. I can take care of that. But eventually there'll be you'll get rid of the low hanging fruit, and the problems that remain may be hard to understand, or even if the developer understands the problem, they may just not know how to fix it. It may not be obvious what should I do next? How do I fix that issue? And when you get down to those issues, that's a sign where it's time to bring in some help. The other way that is that when it's just not worth it anymore. So when you get to a certain point and you've kind of cherry picked all the low hanging fruit, like I said, fixing the next set of problems without help is going to be a huge pain. It's going to chew up a lot of resources and a lot of time. And you could be doing something else with that time. You could be developing the software with that time. You could be, there are more valuable things you could be doing with your time. And that's also another sign that it's time to bring in an expert, because it'd just be a lot more efficient to get some help at that point instead of, spending hours and hours and hours agonizing over how to deal with the remaining issues.
And I found that that slide that you had that had the stacks of money and how each increment was 10 times more is super powerful, especially for a leadership team who really, I hear it, with the large companies like a Humana or, like a very big company, they're obviously security focused, but for other companies that just are like, security will handle it, whenever, from a C-level, I think that stack of dollars speaks volumes. It's huge when you look at it that way.
Yes. And that's not just for security issues. It's true for other types of bugs as well. So functional problems and performance problems will manifest in the same way in how disruptive they are. It's just what's interesting about the security issues, though, is it's really even worse, because
a
security issue isn't just a regular defect. I mean, it is a regular defect. So yeah, it's 10x, just like everything else. But it also has those other consequences, right? You could have a bug bounty, you could have a security event, your reputation could be affected. Folks could lose confidence in the product. They could feel like you're disrespecting their privacy, right? There's all these other consequences that you don't have with ordinary issues like you do with security issues. So it tends to be even more exaggerated with security problems, but it is true for any kind of a software defect. It is much more expensive to fix later.
And I think Jim brings up a pretty decent point, and he mentions in the chat, likely to be different when working with commercial clients versus government defense. And I think it's also probably slightly more also project type, exactly what you're building. But do you see that a lot with, understanding right off the bat, like what security level is needed and really understanding that and then trying to implement that? Or is it, you're still following the same pattern? Just from your experience, I think he even mentions, big iron solutions. So I know there's a lot of free stuff out there, but I imagine those are the ones that you gotta pay for. So just some of your experience of working with, let's say, larger enterprise, clients that might have a heavier focus.
Yeah. So are you asking what types of tools a large enterprise might need? Like if these might be too small for them?
Yeah, just thinking about like right off the bat. So he mentioned, they were well down the road working with SonarQube when they told that wouldn't cut it. So something that, we can think about when we're talking to potential clients to have that conversation up front and really understand what the minimum requirements on the security side might be.
Yep, where the free tools tend to kind of reach their limit is it is somewhat based on the project size, but I think it's more so based on the number of projects. So as you have more and more and more projects that you're trying to manage the security of, the reporting, the ability to organize the information, the ability to data mine the information becomes more and more and more important. If you're a small shop and let's say you have 3 applications, you can probably manage the security of a few apps, right? You can get them all scanned and get them all remediated and get them all patched and keep them monitored and work really hard. And if you put a lot of effort into it, you can do it. But when you start to get, 7 projects that you're managing simultaneously, or 10 projects, or, I've seen companies that have right around 1,300 projects they're trying to manage simultaneously. Those little tools, those free tools, they don't scale like to that extent, right? They're not going to do, 1,700 scans per quarter, right? They just can't handle that kind of volume and that kind of scale. And even if they could, or even if you chain together a small army of them using containers, and had 1,000 copies of Zap running at the same time, how are you going to manage the reporting coming back, right? So that's really, for larger customers, that's really where you get a lot of value out of the enterprise tools, because you can scale up to the size of your operations, and it doesn't take you 10 years to get, one complete scan of everything in your entire company. And there are a lot of large companies that have hundreds of projects going simultaneously. In fact, the Fortune 100 probably all does, to the for the most part.
Cool.
Well, thank you, Jeremy, so much. This is all really good information and definitely valuable learning as well. Is there any other questions before we wrap up? Does anyone have maybe one more? Okay. And thanks, Katie, for sharing Jeremy's contact information in the chat. We do appreciate you all, as always, for joining us on your lunch hour. You could be spending that time anywhere, but we appreciate you spending it with us, and have a wonderful day.
Oh, real quick, before we wrap up, we have added some IC Agile classes with Damon Poole, as well as an ACSM with Chet, and a PMP evening class, and we'll add one with Jeremy as well, an OWASP class. So look out, it's www.keptraining.com. And I totally forgot to say that at the beginning, so I had to wrap it up at the end. But thank you all as well. Sorry to jump in.
No, you're good.
All right. Thanks for having me. Really appreciate it.
Thank you, everyone.
Thank you.
Sounds good.